Hello and welcome to the penultimate exercise session number 11, where we'll be looking at numerical Python with NumPy. So I can see that the first couple of exercises has to do with getting started with NumPy. So I think we'll just jump into those, and I'll talk a little about what it is. So NumPy is an external package to Python, which is used to perform linear algebra operations. So those are things like representing vectors, adding vectors together, and multiplying vectors with matrices. And as it turns out, those are some of the most useful things you can do in engineering and the sciences. So that's why NumPy plays such a central role, because it's basically the best way of doing those operations. So in order to start NumPy, we need to go into Python, and then we need to import it, because NumPy is not something that comes built in with Python. It's something that you need to manually install, and you did that in the first week when you set up the toolbox, but we need to remember to import NumPy like this in order to access it. So I'll import NumPy, and then it's convention basically that you give it an alias like this using the as syntax, and this is just a name that I come up with, but everyone comes up with the same name. So everyone just calls it NP. Now what this syntax allows us to do is to access all the methods in NumPy by typing np dot, and everyone just does this. So it's good to just get familiar with this and accept this is how you work with NumPy. Okay, so what can NumPy do? Well, suppose we wanted to work with we have an application that needs to work with vectors of some sort. So one way of storing a vector is to store it as a list with 3 elements. So this could represent a 3-dimensional vector. But if we do that, we don't have a convenient way of representing arrays, and we don't have a convenient way of multiplying vectors with arrays. And this is where NumPy comes in. So NumPy has a equivalent way of representing data like this that just gives us a lot of additional functionality that turns out to be super useful. In order to access that, we need to turn this list of numbers into a NumPy vector, or array as it's called in NumPy, and we do that with the np.array function. And we can store the output of this function in a variable. I'll call it v because it's a vector. And then we can see what type v is, and just confirm that v is an object of the class numpy.ndArray. NdArray is like the base class in NumPy. It represents n-dimensional arrays, that is vectors and matrices. So NumPy comes with a lot of built-in functions. It can be a little bit daunting, but it's worth just exploring a couple of them. So first of all, it comes with the zeros function. And if I give it a number 5, we can see that it creates a vector with 5 dimensions, that is 5 elements like this, and they're just all set to zeros, and that's why it has this name. Maybe not so surprising, there's a ones function, and ones create an equivalent one with just all ones. So you can of course imagine that there could potentially be like many different functions like this, but it turns out that if you have these two, you can do most of the things you can imagine. One other. That being said, there's another one that's very commonly used called arrange. So let's just explore that. If I type np.arrange, not with 2 r's, with 1 r, and I give it an integer, maybe I give it the integer 6, we can see that it creates a list it creates a vector with 6 entries, and the entries are the integers from 0 up to 5. So 1, 2, 3, 4, 5, 6. And you can maybe imagine that this could be useful in conjunction with loops, or if you wanted to, yeah, it's a little hard to see why it's useful right now, but it turns out that this has a lot of uses. Of course, another way of accomplishing this is to create a list that just has the right standard Python list that just has the right elements, and then converting it to an array, and that's completely fine. We're just mentioning these because you might encounter them in other people's code, or you might find them useful yourself. So so far NumPy just looks like another way of making a list, and that is pretty much what it is in some sense, but there are important distinctions, and that's the next thing that I'll look at. So let's say we create a list with maybe 4 elements like this, and now what I want to do is that I want to add this list. Let's store it in a variable called v, and then I create another one called w, and this can just be all ones. So maybe I create 3 ones with 3 elements that are all ones. So now I have these 2. Now suppose that I want to create a new list, I may start starting to mix up lists and arrays, and that's bad form. Suppose I want to create a new array, and I want that array to be 0, 1, 2, 3, and then 1, 1, 1. So I want to basically put this at the end of this. So remember that in regular Python, the way we would accomplish that is just type take the first list 1, 2, 3, 2 and 3, and then we would just use the plus sign, and the plus sign would just take care of it, and it works super naturally. NumPy want these things to actually represent physical vectors, and if we try to add vectors together, like what NumPy feels should happen is that it should perform normal vector addition, like in mathematics. So it should add this number to this number, and this to this, and this to this, and then there is maybe a little bit of a problem here. And actually there is a problem, because they have the wrong dimensions, so we cannot add them together. And it tells us, it complains that they have the wrong shape, as it's called, and that simply refers to them having the wrong number of elements. So in NumPy we would need to do something else in order to accomplish that. And that something else is to call the concatenate function. And this is where we start to get started with the fact that in order to use NumPy, you just need to know certain things, and this is one of them. So if we call the concatenate function, and we remember that it needs a list of the things we want to concatenate together, it will actually do the trick. But this is something that one just has to know, or has to Google, and Google is typically excellent at telling people the answer to these kind of questions, because so many people have troubles remembering these special functions, or maybe don't know what they're called. But this is how we could accomplish this task. So maybe this is also a good way of mentioning that typically things are a lot more natural and nicer looking in regular Python with regular lists than it is when you are using NumPy's arrays. Because in NumPy you typically need to remember a lot of stuff like this, whereas with Python lists it looks a lot cleaner. So the take-home message from that is basically that if you need to do something that involves lists of numbers or other stuff, and you can do it with regular Python lists, so you don't need to use all the linear algebra stuff, you should just use lists. So NumPy is for the case where you need to work with like you actually need to work with something that requires matrix vector multiplication or other stuff that NumPy excels at, because it comes with a little bit of a mental expense. Okay, that being said, most of the things you typically want to do with NumPy arrays function the same way as vectors. So here are some examples. So let's say we want to print the first element of the array. So by the array, I guess we mean this one, so let's store it as a variable x, and then we can access the first element by just indexing it like this. And this indexing works exactly the same way we would index a normal Python list. So if we want to get the last element, that's the next task, we could use you would get the length of the list, subtract 1, because remember that when we index in lists, the indexing starts from 0, so we have to remember this has index 6. And then we could do like this. That would give us the last element. But similar to regular Python lists, it supports a negative indexing. So negative indexing will like start here with 0, and then -1 jumps over and selects this element. So that also works. The next one is one where we need to print the first 3 elements. So the way we would typically do that in regular Python is that we would use slicing, and that also works in NumPy. And when we slice, we get a new array. And if we want to print the first, third, and fifth element of the array, we can use this operation, which is slicing, but where we jump in increments of 2, starting at 1, and just this syntax means that we end at the last element. So that will give us the first, third, and fifth element. You can see that if I chose to start at 0, we would get, just print it out, we would get this, 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 and this. So that is what this will return. Change the second element to 5. So the second element is element, just element 2 is element number 1 because it's 0 index, so that would be the second element. And in order to change it, we can just use assignment like this, and then we can see that it has changed it to 5. Okay. Now we need to create a 2D array. So when you create a 2D array, the way it works is that you create a list of lists. So the lists in this case, let's just try to do it as an experiment. So the list of lists in this case looks like this. Like this. So this is a list of lists. We can get the first list. I know the syntax is a little bit ugly, but that selects the first element of the list, which is this list here. Now we can try to turn that into a NumPy array using np.array. And I'm going to store it in the variable a. Then we can see that NumPy automatically stacks the two lists together like this, because inside NumPy this actually represents a matrix of dimension 2 and 3. This is how we would create this is one way we could create a matrix of that dimension. Another way of doing it is that we could take this array, and then we could, this array which has which is a vector, and then we could reshape it to have the right dimension. Like what do I mean by that? Let's start by creating this this array and store it as x, like this, and we convert it into a NumPy array as so. Okay, so what I basically want is that I want to turn this into a matrix of dimension 2 and 3, and I want the first row to be these elements. Wait a second, that doesn't quite add up, does it? Four. Oh, so that's because I selected the wrong example. I was just counting the number of elements, and there were too many elements down here, so that was what was confusing me. So let me actually do the right example. And then, as I was trying to say, I wanted to turn this into a matrix, and the first row should be these 3 elements, and the next row should be these 3 elements. You can do that using the reshape method. So if I take x and then say x.reshape, and then give it input arguments, I think we give it as a tuple like this, it converts it to have the right size. And it's important to here remember that it creates the rows first, because you could imagine that it took and created, said this element goes here, and this element goes here, and this element goes here, and this element goes here. So it created it columns first, but it doesn't do that. It creates it rows first. Another thing you just have to remember. And this is something that I made mistakes with more than once. And the only way to really combat those kinds of mistakes is to try with small examples and just verify that it does what you think that it does, because otherwise you'll easily make mistakes. Another way of doing it, I think, let's store it as a variable b, like this. So apparently that we can access the shape using the dot shape. I knew that, but apparently we can just set the shape to having a new value. So let's try to do that. Let's set it to 3, 2, and now we can see that B has been rearranged. And again, the way it rearranged it is that it starts to read it from the rows first, but it forces it to have shape 3, 2. So it starts with this element and put it on the first, this element and put it on the second, this element then goes on the third, and this goes here, and this will go here, and so on. So that's apparently another way you can change the shape of an array. I didn't actually know that. I always use the reshape method, but I guess you learn something new every day. Okay, so I think I'll end here in order to not make this video too long, and then I'll continue with the next warm-up exercise. So thanks for your attention.